Okay, this video is to present how Inventor can be forced or made to force and solve flexible assembly not properly and still consider this as mm, as correct solution. So what I will do now is I will present to you the jack assembly. Please have in mind this is the jack and it is named basic flex here. It is named basic flex because I have simplified the assembly only to have two components, two parts, and to be as simple as possible. So we have a cylinder that is basically grounded, and we have a piston that is constrained to the cylinder in such a way that it only has 1 degree of freedom, that is translation about the axis of the cylinder. This assembly also has two position representation: the master, in which the cylinder is grounded, and the flex position representation, in which the cylinder is ungrounded, so it is free to move inside the assembly. So, having examined the construction of the assembly that I will use as flexible, we have to use this knowledge later on. So the basically the conclusion is that this piston can only move along the axis of the cylinder, and it is constrained in such a way that it cannot be flipped upside down or rotate or anything. So this made constraint should prevent the cylinder from rotating, from moving upside down or moving out of the cylinder or moving sideways, or generally it should only be allowed to move along the axis. So I will now close this assembly, not saving it. Here is a basic flex assembly in which we have two supports. This support is fixed, the other support is constrained to the first support, so its position is also fixed. And I have the flexible jack that we have seen just a second ago in basic flex. So this jack is now in its flex positional representation. So in this position, first of all, this cylinder should not be grounded but should be ungrounded. This is some inconsistency. I'm not sure whether it is or it is not. So this assembly is constrained to the support. The constraints are done in relation to the cylinder part. So all the constraints involved are using the geometry of the cylinder part itself. None of the constraints is done to anything that is part of the flexible jack assembly itself. What I will do now, I will try to force Inventor to solve it against internal constraints of the flexible assembly and still validate the solution as correct. In this particular case, I will try to constrain the upper flat surface of this of the piston to the upper flat surface of the upper support pad with the made constraint. So I am trying to force the piston to be dragged out of the cylinder, and also to be placed against the made constraint bottom to bottom that is in the, so basically against this one. As we can see here, Inventor proposes us solution in which the green cylinder is placed against the constraints that are defined on the top level assembly. So in this particular case, mate 2, and also as we can see, mate 4. This is enough. I will try to accept the proposed solution. As we can see now, the cylinder is brought back to where it was, so these constraints are now met, but these constraints are not met. If we can see here, this mate constraint is obviously not met, because these two surfaces, this one and the inner bottom part of the cylinder, I will make some view to show. So generally mate 5, that is internal constraints of the basic flex jack assembly. This mate constraint is involves bottom surface of the cylinder hole and the bottom surface of the piston. In this case, this is obviously not met, because these two surfaces are now flush, plus the distance between those two surfaces is not as it is defined in the mate 5 constraint within the flexible jack assembly. Also mate 4 is not met, as we obviously can see that these two axes do not line. And also mate flush 3 is not met, as we can clearly see that now. As I have proven, inventor solves the assembly badly when I try to apply the constraint mate 5 in this case, that forces the flexible assembly to break its internal constraints to meet the top level assembly constraint. In this case, inventor does not show any problem with the assembly, so the software recognize this solution as valid, although it is not following the constraints that are defined in the basic flex subassembly of the jack. So what I have shown here is 100% repeated. It is 100% repeatable for this assembly. I am now, let's say, waiting for your action response in this matter.